Hi, good morning from the Cooper Laboratory in good old Carrollton, Virginia. What we have here is a simple LED light chaser circuit that primarily consists of two main components, and you can see them kind of ducked in like right there and there. That's the N555 timer and the CD4017 counter circuit. All right, and we have some additional things added, like a potentiometer right here and a capacitor right here, and some resistors so we don't blow those LEDs up. What the 555 timer does, it is configured in the stable mode to produce a square signal wave. Or signal, if you will. The frequency of the signal can be adjusted, and I'll explain that a little bit later, which determines the speed of the LEDs or that will chase or sequence in like 1, 2, 3 motion here. The next thing I'll go over is that CD4017 counter. It's a decade counter with 10 decoded outputs. That's why we have 10 LEDs there. It scrolls bits at its output based on the rising edges of the signal, and it's clock pin 1, 2, 3. When the counter receives a square wave from the 555 timer at its clock pin, it advances its count, turning on the next LED in sequence, 1, 2, 3. The potentiometer that we have here, or variable resistor, as the colloquialism, I guess you can call it. Listen to me, being all electronic engineer type guy. But anyway, I digress. It's added to the circuit to control the frequency of that square wave that 555 circuit generates. By adjusting this resistance, we can change the time period of the square wave and hence control the speed of the LED chase. So the additional resistors in various parts of the circuit, as you can see, they're used for current limiting to protect the LEDs from blowing up, essentially. And then we have this capacitor here, which is added to the circuit along with the resistors and potentiometer to control the frequency of that square wave generated by that 555 timer. The resistor capacitor combination determines the charge and discharge times of the capacitor, which in turn determines the time period and hence that frequency of that square wave that we're sending over to that the decade counter. By choosing these components, we fine-tuned our operation, so to speak, and made this circuit be able to kind of, as you can see with that dial turned all the way to the left, that counter right there it's really counting like bum 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 bum, so that's like a pulse width modulation, so it almost looks all on, but it's really switching. As you can see, if I turn the dial a little bit more to the right, you'll see it blinking. That's the switching going on that you're seeing. So I think this explains everything. If you got any questions, ask the guy that is named Arnaldo Rivera or Noah Trevor, because I don't know anything. Thanks. Appreciate it. Have a good one.